Oh boy. Projectile motion, volume 2. All right, let's get right into a question. An object is thrown from a cliff that is 140 feet in the air. The object has an initial velocity of 64 feet per second. Answer the following questions. Okay. Number 1, how long is the object in the air for? Okay, so let's draw our little diagram because the diagram is going to help us understand what we're trying to find here. So my quadratic function, now it says that it was thrown from a cliff that's 140 feet in the air. So that should tell you right away that it's not going to be thrown from ground level, obviously. So it's going to be thrown from somewhere above here. And since we know that we're talking about projectile motion and it's going to be a quadratic in nature, parabolic in nature, it's going to have that shape. So remember the 4 things that I can ask you, right? Well, really 5 because we talked about yesterday because Alex wanted to make sure that we talked about that last one. So initial height is my y-intercept. Okay, so initial height. Okay. The ground level represents the x-axis, which represents the x-intercepts or the solutions of the quadratic. Now, because we're talking about something that's in real life, I need to represent that as how long the object is in flight, meaning how long is it going to be in the air for. Or the other way you might see it is when will it land. Okay, so this is an x-intercept, and this is the when does it land, or how long is it in the air for. They're the same question. Okay. Now, the vertex is also important because there's 2 questions that can come from the vertex. The first question is, what is the vertex? Right? And that's kind of, I guess that's probably more often asked. Now, the what is the vertex part represents how high is it? Like, what is the height of the vertex? Which is the function's value at negative b over 2a. Meaning find negative b over 2a and then plug it back in to find the function's value at negative b over 2a. The other question regarding vertex is, well, when did it reach its maximum height? Which is negative b over 2a completely. So that'll be, when did it reach its max? Okay. Now, the 5th question, which is a little bit more challenging, is how long is the object above a certain level? Now, for instance, in this question, this y-intercept represents 140 feet, so we already answered one of the questions. I might ask you, how long is the object above 200 feet? Okay, so let's just call it like 200 is this line here. There are 2 spots where it'll be above 200 feet. Meaning I'm going to have to get both values, so solve the quadratic as it's equaling to 200. So like f of x equals blah, 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 or 200 equals blah, 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 blah. I need to find both x values, right? And then I'll have to subtract them, meaning I need to find the difference between those 2 values. So think average rate of change there. Now let's get back to the question itself. Here is my breakdown. So the function is negative 16x squared. The initial velocity is always the b term, plus 64x plus 140. So this gives us the roadmap of how I can solve all these questions. So number 1 says, how long is the object in the air? So how long is it in the air for represents, if this is where it's thrown, all of this area here, or all of this line here. I'm looking for an x-intercept. So I'm going to use the quadratic formula. I could actually factor some things out here, like I could factor at least a 2 out, so I can make it a little friendlier number. But use the quadratic formula in order to solve that, okay? Now, I'm not going to do that in the interest of time, so I went ahead and got the answers for you. So if I want to know how long it's in the air for, you're going to have to round to the nearest 10th place, and that should be about 5.7 seconds, okay? So when you solve with the quadratic formula, you're obviously going to get 2 answers. Now, keep in mind, because this wasn't launched from ground level, the parabolic motion, the other intercept will be negative, so we have to obviously ignore that. So the positive intercept is 5.7, okay? Number 2, when will the object reach its maximum height? When being the key word here, okay? So when represents an x value because x-axis represents time. So I need to understand, I'm looking for the negative b over 2a portion of the vertex or of the max, okay? So when I solve this for negative b over 2a, I'm going to get 2 seconds, exactly 2, okay? Let's scroll down. Let's do a couple more problems for this. Okay. Number 3 says, what is the initial height? Okay, so I'm giving you a really, really easy one there, okay? I should have erased that, sorry. Okay, so what is the initial height of the object? Okay, well the initial height is when I plug in 0 for x and solve for y. Or it's what it says, the problem says it is, it's 140. So the initial height is 140 feet, okay? Number 4, what is the max height? Okay, so this is kind of a piggyback on question number 2, because 2 said when is the max height, meaning the x value or negative b over 2a. What is the max height is a height question, meaning a y value question. So this is where I'm gonna plug in or substitute negative b over 2a, whatever I got for that value, which we got 2, right, 2 seconds. I'm gonna substitute that back in for x and solve for y, okay? And when you do that, oh, also, please be careful when you do that. You're not multiplying 2 times negative 16 first. That's not PEMDAS. You're squaring 2, okay? So when I do that, I'm gonna get 204 feet, okay? Now the last question, right, I should have put Alex's question. I'm not gonna do that on the test, obviously, because that's silly. How long will the object be above 180 feet? So this starts as the function f of x equals negative 16x squared plus 64x plus 140. But now I want to know a specific set of values at this y value. Because remember, feet represents the y-axis, which is a y value. So I need to plug this in for y, okay? So what's gonna happen here is, I'm putting 180 here. And I'm gonna solve this quadratic as is. Now, the one thing that you obviously wanna do is, we're obviously gonna subtract 180 on both sides, because I've gotta combine like terms. So I'll have negative 16x squared plus 64x minus 40. I want to solve that now using the quadratic formula to get both values, okay? Now, typically, I'm going to ask you a value that it actually will encompass. Like, if I said how long it'll be above 400 feet, well, this quadratic doesn't hit 400 feet. The max value is 204. So that would be impossible, right? Because it doesn't even touch that. But I know because it has a max of 204, it's got to hit 180 on the way up, because remember the initial value is 140, so 180 falls between that and 204. It's going to go up to 180, go above 180 for some time, and then on its way down it's going to hit 180 again. So I know that it's going to hit twice. Okay, so instead of 200 here, let's make this 180. So when you solve this quadratic for both values, okay, now this one I only kind of estimated because it was a little bit funky. I think the furthest value was like 3.2 something. The closest value, or the closest intercept, was about 0.79 or 0.75. So we're gonna be subtracting those two values. Now, I just put about 2.5. Okay, so if you got something in that ballpark when you did it, then you're fine, because I don't know the exact answer, but it's close to that, okay? So that's how long the ball, or the object, the projectile, is above 180 feet, okay? So, hope that helped. There's a quiz and a fever. Make sure you do the fever because there's questions just like this for another quadratic.